Your calculators out,
Sweet.
and I want to talk a little bit about graphs. And what do those values mean when they're in your graphs, when they're in the calculator? What does it mean when you have some weird value? How can you figure out parts in the calculator? Especially for stuff that's not really nicely factorable. So what I want to do is just get a function and put something in that may not be the easiest one in the world to graph. Let's see if I can get one that'll work.
Mr. Murphy,
Yes, sir.
can I go to my locker and get my calculator?
Yes, sir.
Do I need my agenda?
Yeah, I'm signing for you. So let's see if I do this. Negative 0.003 x squared plus 0.62 x plus 3. Okay. That's slowly going through there. What?
Nothing. Oh, no, nothing.
So, let me pull this out so you can see it.
We're good. We're all good.
Here's what I threw in the graph. Negative 0.003 x squared plus 0.62 x plus 3. Now, obviously, when you graph that, it's very difficult to see what it's doing. Do you agree? Okay. We do know one thing for certain. We know where its y-intercept is. It's at 3. Because the y-intercept always occurs when x is equal to 0. So that's good. We know something. You okay? So let's take a look, and what I want to do is kind of figure out what I have to do with my window to see the whole curve. Do you guys know how to adjust the windows?
Yes.
No. Okay. There's a button on your calculator that says window. It's right next door to the y equals button. On there, it's probably set as a 10 by 10 window screen. As of right now, that's not letting us see everything. So what I'm going to do is change my x maximum and change my y maximum to try and see if I can start to see my curve. So I'm going to change my x maximum to maybe 50, because I don't know how far out this curve goes, and maybe change my y maximum to 50 as well, just to try and see if I can start to guess where this is going. We might be able to see it better. So as you regraph, you'll be able to see, am I seeing the whole curve, or do I have to adjust it further? I have to adjust that further, don't I?
Yeah.
If you look at the way that thing was curving, do you think what do you think my next my x maximum should be as the test? 100. Good. That's great that you thought of that. Because notice I was going up still. If I do 100, maybe I might catch it. Did I need to have my y max up so high? No. Could I adjust that to lower it down a little bit so I might see it a little bit cleaner? Absolutely. Go back to your window. I'm going to change my x maximum to, you said it was over 100. You've already checked?
Yeah.
Well, I'll do 125. I'll do 125, and I'll leave my y max by 1. Okay? All I'm doing is messing around with the window to try to figure out. All right, well, it's more than 125.
How about
You went 250? Okay.
250. No.
All right, so we have a curve.
But mine doesn't show up.
Okay. Now, when we're looking at this in our calculator, there's a few things that we can do. Obviously, this is a what times what is negative 0.009 that adds together to be 0.62. That's a whole lot of no fun to try and figure out. I can use quadratic formula and do all that other stuff. But one thing for certain, if I'm looking at my graph, if I'm looking at the graph, this point right here would be the what? It would be the maximum, wouldn't it? It's the vertex, right? Since it's the high point, this would be called the maximum. Now, if you look on your calculator, under where it says trace, second trace, you're calculating, there's an option on there for you to calculate the maximum. So what we're doing here is we're going to try to figure out the maximum values, basically finding the vertex of a parabola. If we select maximum, which is option 4, or scroll down, it's going to do that whole left bound, right bound thing again. So on this curve, where should I place my cursor for the left boundary? So the left of where it looks like it's the tallest spot. That's all it is. The formula was negative 0.003x squared plus 0.62x plus 3.
What do you have for that?
For this one,
Yeah.
change the window to a 50 max on the y and a 250 max on the x. Remember how we did left bound, right bound last week? No?
Yeah.
Okay. When I'm looking at this left boundary, right boundary, when we have this curve, I'm going to move my cursor to the left of where it looks like the maximum value is occurring, and then I'll move my cursor to the right of where the maximum value is occurring, and then hit enter a couple times. So I'm going to say my left bound is about there, and hit enter. Then it automatically is asking me where's my right boundary. Well, I'll just move it to the right a few, and hit enter again. Guess, I still to this day have no idea what guess means, so we're going to say
Fish tacos.
fish tacos. Very good. And hit enter. And this is giving me a maximum value at 103 and change and 35. Okay? That's where my vertex would occur. It's also the halfway point of the curve. Okay? It's also the halfway point. It also, so we have a maximum, let's see. This is giving us, let me go back to my, there's our maximum. Shh, don't whistle, please. So it gives me a maximum at 103 and change and 35 and change. It's the halfway point of my curve, but I can't double that x value to give me the farther zero, can I? If you look back at your graph, if my curve was both, if this is my center spot, if I double this value, does it give me here? No, because your other part would have to be at 0. Okay? It's a mistake that people usually do. So the other option, if you go back to that second calculator that you have, there's an option on there to calculate 0. Second trace. Option number 2 is to calculate 0. Okay? It's asking me for that left boundary. Well, I'm already over this side here, so I'm just going to scroll this down when it's close to the x-axis. And what's nice is that you can see where it gets really close to the x-axis because the y value gets smaller and smaller and smaller. So you want to pick it right before it goes to 0 or negative.
It's like the 0.5.
Yep. Oh, it just passed it. Yep. See that at 0.5 and change? Yours might be a little bit different depending on how your is set, but it should have some decimal before you get to 0. So I'll make that my left boundary. Pick the right boundary, which basically is the very next point because it goes negative. So somewhere between 0.5 and negative something, it crosses the x-axis. That'll be calculate my 0.
Negative what?
So it's giving me a 0 at 211.397. Okay.
Does it really matter like what points you do as long as they're like above and below?
Yeah, above and below you should be okay. It's going to give you a range, and there's going to be a little bit of rounding there. It really, it also does depend on how you set your scale and all that with the x max, x mins, and stuff like that. So what I'm trying to get you guys to see here is that sometimes when you have weird quadratics, weird functions, we can still find vertices, we can still find maximums, we can still find minimums Minimum would be if it was up like a cup. This one's maximum because it's down like a frown. You can find distance, okay? The distance from 0 to here was 211. There's another 0 on the other side that was negative. We could go ahead and calculate that as well if we want.
No.
All right? It's just these little things I'm trying to show you guys that the calculator is able to do. All right? Questions on that? All right. So let's take a look then as we start. Oops, go on. As we start discussing how do we set up and solve some of the quadratic style word problems. This one isn't on there. I wanted to show you like a very easy setup before we. What I'm going to do here is pick and choose a couple of these examples that are in this little packet. And it's basically maybe 10, 12 word problems throughout the whole chapter that I've chose. There's a couple other ones that I'll add in here tomorrow when we start talking about ones that are cost-based. Sell something for so many dollars and you sell fewer if you change the price, things like that.
So kind of what we did in the last section.
Yeah, very similar, very similar. Not as complicated though. Okay. Do you guys ever play that game Lemonade Stand or Crack Dealer? Kind of the same game. Like, you know how you have lemonade stand, if you raise the price of lemonade, you sell fewer, but if you there's that whole balancing act. Same thing with the crack dealer game. I think the same thing.
You just sell crap.
You're just selling crack then. Okay. You know, it's a hot topic nowadays. Yeah, business is business. Yeah, business is business. So, wow. Anyway, so you're going to make a rectangular stained glass window. That's 2 foot by 4 foot. You have 7 square feet of clear glass to create a border of uniform width around the window to the border to be. So what should that width be?
Wait.
Think about this. You have a glass window, 2 foot by 4 foot. It's rectangular in shape. And you have 7 square feet of leftover glass to create a border around it. And you want that to be of uniform width. So
all the glass.
yeah. You want that to be of uniform width. So if it's always going to be the same width around, what did I just call that X?
Why are you doing that though?
Showing that there's some value X all the way around. Because now, what is the overall width of the picture, including the frame? This would be 2x plus 2, and this would be 4x, 2x plus 4. Okay. I'm adding some value to both top of the border. Okay. So my new area would be something different. So here's what happens. This winds up being a very easy setup problem as you go through it, because
Nice job.
I tried to be fancy and just kind of did one as well as wanted to. You know that the area of the border has to equal the area of the entire thing, subtract out the area of the picture. How much did I have for the area of the border? 7. Area of the border, I have 7 square feet. What's the area of the border and the window? Well, to figure out the area of the border of the window, isn't that 2x plus 2, 2x plus 4? Where did I get the 2 for? Which one, the 2x?
2 x's, there's 2.
X plus x? The new width of,
Yes, 2x, yeah.
that's how I'm adding it. I'm adding it here and here, so there's 2 x's plus the 4.
Oh,
So the whole way, this is x plus 4 plus x, so it's 2x plus 4. That's all.
okay.
Okay?
No, I'm close to you.
And then you have to subtract out the hole in the middle.
So
The hole in the middle was how much?
8.
Isn't that just a quadratic? Okay?
Oh, gosh.
So watch what happens. You have 7 equals, well, 4x squared plus 8x plus 4x, so it's plus 12x plus 8 minus 8. So I get 0 is 4x squared plus 12x minus 7. Would you look at that? Okay. Now we've thrown ourselves into a good old-fashioned quadratic.
But now,
So when you get into the quadratic then, how do we solve that?
Factor.
You can factor it, yeah. Or could we use a graphing calculator to figure it out quickly?
yes.
Good.
Well, let's see. Let's go back to our, you guys, let's go back and reset our calculator and show you guys a little shortcut sometimes. I'm gonna go back to my y equals, clear it out. I'm also gonna go back to my window and go back to a negative 10 by 10.
Or you can just put
Second what?
712.
Yeah, that'll reset everything. It's fine. You can do that too. What was it? 4x squared.
4x squared plus 12x minus 7.
I'll just watch you do this.
What are we looking for?
Everybody getting that?
4x squared plus 12x minus 7.
Your arm's broken?
Yep. There you go.
I was just broken. Because if it's broken, it would be way worse. I mean, this person here, it's been hurting ever since.
So if you look at that, notice you have 2 zeros. Everybody see how you have 2 zeros?
Yeah.
One of those zeros is a negative value, which means I'd be using negative amount of glass.
It's not
I can't do that, which means I need to figure out the zero that's on the positive side. So can't I just hit second, calculate 0 of the right side one, the positive one? Does that make sense? So I'm going to move my cursor closely. My left boundary this time is going to be below it because I'm going to the right.
Do you have to put like the first one in first? Like, does it matter which one you put in first? Like,
Left and right bound?
yeah.
Yes. If it asks for the left boundary, you got to be to the left of where it goes across. Otherwise it won't
Mine's
work.
going up so high.
How do you know it's the left?
You have to think about what the curve is doing. Think about where you're being placed. When you're looking at the curve, if I want to figure out this 0, the left of it is below it. The right of it is above it. If it was flipped over, the left of it would be above it, the right of it would be below it.
Okay.
Because you're always reading it going from left to right. Okay? It's a great question.
Oh.
Okay, that's a great question. Everybody hear that? How do you know where to put your left and right boundary? Remember, you're reading this like you would a book. You're going from left to right. Where is the curve above or below? That kind of thing. Somebody hit enter. Pick my.
What was it? Point like 4, 5, 5, 4, 5.
I don't remember exactly, but we should wind up in 0.5. So what should my width be?
Mine's done.
Half an inch.
I had a question.
Huh?
I'm so confused.
How'd I get my left and right boundary?
Yes.
Okay. Give me 1 second. Listen. When you get your left and right boundary, remember.
I have the left hand.
All right, now scroll above it. Now hit
Is
enter again.
it bottom
One more
right?
time. There we are.
That's it.
That's it.
No.
Wait.
Well, that was
You do the
easy.
bottom first and then the
Oh,
top.
that's probably why.
Yep. Remember, guys, you have to figure out if you're above or below the curve. So you're going from left to right, and that's where people mess up. And if you wanted, you could have factored this problem as well. But this is just finding the zero sometime a little bit quicker.
But if I
Yes,
did
ma'am.
And then on the other side of the graph, would the bottom still be the left and then?
On this one here,
Yeah. Would it,
no,
or
the
top?
left would be here because you're
Okay.
reading it going from left to right. So this is the left boundary. Here's the right boundary because this is in between it. It's looking for values in between.
Alright.
Okay. Yes, ma'am.
So then if it's up like that, the top one is the left, the bottom one is
Like this one
on the.
for this side.
Yeah.
Yes. Okay. That's why I like to use a little bit of these, because you get used to it. Because by the time we actually start using these a little bit more, it's going to be old hat. It won't be an issue.
That
Okay?
one's difficult to factor.
Well, you can do it. It's just 4 and
You gotta put negative
4,
seven
28 and
before.
what is it? 28 and they get 28 and 12. So that'd be what? 14 and 2.
Oh.
Wait, that's
Yeah.
what.
It's factorable.
I took 4 out. Not a good idea.
No, not a good idea. No. Bad things, man. Bad things. So that's the idea here. Another style that I want to show you. See which one was it?
What do you do with 14 and negative 2?
So on a test, like if we have this kind of question, can we use our calculator?
If you have your calculator at that point,
Yeah,
yes.
say,
Wait.
use calculator.
Let's go to the one that talks about shoes. 99 on yours. This is one of those cost revenue style word problems that mirrors itself for a quadratic. It is it's very, very easy to work with once you understand what in the world it's talking about. So you have a shoe store that sells about 200 pairs of basketball shoes each month when they charge $60 per pair. For each dollar of increase in price, about 2 fewer pairs per month are sold. How much per pair should the store charge to maximize their monthly revenue? So, here's what happens. You have two things going on. You have cost, like your price, and you have sales. Since we're talking about quadratics, which means we're probably going to set up some form of a quadratic.
Oh. Nice.
Okay? What is your initial cost?
60.
60. And how much do you sell at 60?
200.
See what I'm doing there? I'm separating cost to sales. Very, very straightforward. Okay? Now, for every dollar increase in price, which one did that go to? Cost?
Cost.
Do we know how much
1.
plus 1x? Because that value of x means if I increase it $1, $2, $3, that's the x becomes and it changes itself through. How many fewer do I sell?
Minus
Minus 2x.
Gee, where do you put that in your calculator?
In the y.
In the y equals.
Here we go.
Okay? Now, they're trying to do what? Maximize their monthly revenue. So that means we have to figure out where the maximum is going to be. Obviously, if you notice this, if you did FOIL this out, you'd have a negative x squared term, which means you'd be down like a frown, which means you'd have a maximum value for your vertex.
Let me graph.
You might not see it, so you have to adjust your window.
I don't
Better
see
yet,
anything.
if you do this, if you put that in, oops, wrong one. Let me clear that out. What was it? 60 plus x, 200 minus 2x.
I didn't see anything.
Go to your table. Go to your table. And obviously, this being a parabola, it's going up, then eventually it's going to come back down. Good morning, Judah. How are you? Mr. Salinas, they're towing your car.
You can't even drive.
I was just
Oh, they stole your bike. They're towing your bicycle.
not talking about.
Oh, they stole your bus. Now, what I'm saying here is if you're not sure where you're going, if you just scroll through your table, at some point in time you'll notice that it's going to go up and then it's going to start coming back down. I'm hearing people say it's at 20. So somewhere around 20,
Wait, it's what?
actually you might even notice that at 20 would be the maximum. Do you see that? Because look at the values at between it.
Oh, I see.
Notice you've got symmetric twins coming off of it. Everybody see that?
Yes.
So with your vertex, by just looking at the table, you know that your vertex is going to be at 20, comma, 1280 or 1200, 800, 12,800. You can't count that high. I don't care that those large bills.
That one says
Did that make sense? I mean, we're quite literally using the calculator to help us come up with ideas of what these things mean. Right? They're not supposed to be difficult. Let's see.
Are we done with that problem?
Yeah. Well, your max. You just basically find the maximum. The maximum would be at 20.
Oh, okay.
So if you think about what they're giving you there. Let me reread that from the question. We knew that was at 20 and then 12,800. So if the value of x, if x equals 20, then you had a y value was 12,800.
Okay.
So how much per pair should you charge if the x value is 20? $80, exactly. Perfect. Because what they're talking about here is not just the value of x, you take that and you use it in your function, your cost of sales function. So the value of x means how much you should increase it, but by $20, so you should sell it at $80. So it means if you're selling them for $80, you'll make the most money at $12,800. Okay?
And the maximum revenue
It's
is
fancy.
just,
What's that?
and the maximum revenue is just the 12,800.
Yeah. And that's what's nice about it. You can use the calculator to help find these things rather quickly. Now, don't get me wrong. There's other ways to do this. This is given to us in intercept form. Can't I find my two zeros, cut it in half, and there's my midpoint, and there's my maximum?
Yeah.
Do that also. This is easier, just scroll through the calculator. Yeah, sometimes it is. Okay. All right. But yeah, there's many different ways of going about these things. If I look at the Big Bertha cannon. I think Big Bertha was on a train track.
I thought it said fire and hell.
No?
Like a handgun.
It was a big cannon. And then it shot. Obviously, but here's the deal. Notice, what's the initial height of the cannon? Look at what's the initial height of the cannon?
1.3.
0. So it's firing from the ground. It's firing on the ground, so maybe it was underground.
What?
Take a look at this as the function.
No.
You gotta redraw.
What's that? I do, you're right. There. I should stick with that, yes. Yes. I never ever in the million years claimed to be an artiste. I am awful at drawing. It is, I will say one thing, when we got a smart board, my shapes became so much better because there was a
You couldn't
button.
draw a kite.
I can't draw a kite to save my life at all.
I don't know, I'm gonna go down.
But anyway, so here's what's going on. Big Bertha was a German cannon that shot very far. Boom! And it blew stuff up. That was fun. Scared you, didn't it? I love my job sometimes. Sometimes, yeah. Well, there's other days when you guys just annoy me. And take it or leave it. Anyway, think about what's going on here. What goes up must come down. Do you agree? Okay. Now this one says the path of the shell can be modeled by some funky thing, where x is the horizontal distance traveled in miles, where y is the height in miles. How far could Big Bertha fire a shell? Now, let's think of this in terms of a different way. This right here is your halfway point from where it starts at. Do you agree?
Yeah.
Now, we could find that as like an axis of symmetry, right? Is this graph fold in on itself? How do you find the axis of symmetry? Very good. That'll give you some x value there, wouldn't it?
Yeah.
Now you've got funky values, which is fine, negative 1.37 over 2 times negative 0.0196. So it's just crummy decimals that you're working with, but it's not that it doesn't work. Okay. So let's see, you get some really weird value for x, right?
34.
What would you do with that value to figure out what y is then?
Divided by 2.
Substitute in, yeah. Substitute back in. There's your midpoint,
What
if
is
you
x
will.
equal?
Some weird number.
34.95.
What?
34.95?
What? That's what I got.
It should be. It should be like right around 35, I thought.
34.9.
Around, let me write that.
It's 1.37.
I got a point.
So we put it back in for x. For y. No. What's x? So is it x or y?
X. Is it x is equal to?
Yes, it is.
Yeah, so what was your,
7.
X
What's wrong?
is equal to 34.
7.47.
No, you're wrong. Try again. Yeah.
Probably the same. We're just, what are you doing?
Let me see. I'll let him know what's
what, you forgot to take the first value. We have negative 1.37 over 2 times negative 0.0196.
Yeah.
Got it.
About 34, almost 35, it's like 34.98.
4.95.
Okay. So your x value
Right.
is at 35-ish.
I got 23, so I should.
Wouldn't that be halfway of how far it can shoot? So how far can it shoot?
23.94.
75.
Up.
Or 70.
Well, you said it with conviction, so we'll give you credit for that. 75!
Well,
Wow.
the 5 and 35 got in the way.
You know, 6 of these, half a dozen of the other.
Yeah.
Yeah, but the idea here is, guys, use
The
the
seven was right.
use.
Is that in miles?
Yeah.
Whoa.
So basically, if you think about it, if you had Big Bertha right now, you could hit Lake Michigan. Seriously, think about it. Think about it. If you go right down I-88,
Well, we have to get
So it
underground
can
though.
shoot up to.
asked was how far could it go, and what was the maximum height. So we figured out that the x coordinate there was about 35. So if you substitute 35 back into here, it'll tell you how high up it went. I think it was, what'd you guys get from the height? It was like 24 something?
Yeah, it was okay.
And your height, your overall height was like 24. It would go up to about 24 miles and come back down. So your overall distance was the other. So it's using those parts of the quadratic. Yeah. I mean, it was 24.96 or something. So this is called, or 35, whatever it was. Okay? Get through as much of those as you can tomorrow. We'll go through a bunch. I got a couple more tomorrow, and then I'll start giving you some review junk.
So it's not, but we don't have that one. We don't have the y by 2 times that by 2.
Remember, when we're looking at this,
It's a great one.
this is your x value going across. This is the halfway spot. Double it, you get here.
Alright.
Because as this goes up, the y value, it's coming back down as it gets to here. So this y value doesn't change. I mean, it's just, and when it gets to here, it just starts decreasing. Does that make sense?
Yeah.
Well,